Hello guys, welcome to another session of Learning with Prepclass. I'm here once again. If you've seen my video before, you remember my name, Tutor Chima. How is it going guys? How have you been seeing our videos? For those of you that have seen a couple of my videos, I believe I've been able to simplify chemistry for you to the barest minimum. And I believe that with my videos, some of the challenges you've had previously on chemistry, especially on the calculation aspect, have been solved, and through my video you've been able to improve your academic level in chemistry. So continue watching my videos, and once you do, you come to find chemistry as a very simple, interesting science subject. So today we'll continue with solving past questions on Jamb Chemistry 2015. And in today's section, we'll be looking at questions 16 to 20. So students, it is customary that you subscribe to our YouTube channel, like our videos. You can drop one or two comments on our comment section box. Look below there, you will also see a notification icon. Click the icon and activate it. Once your notification bell is activated, you'll be the first to be notified whenever we have an educational content like this on our channel. So sit back, relax, as I'll be taking you through questions 16 to 20 of Jamb Chemistry 2015, where we'll be destroying Jamb. We want to destroy Jamb. We won't let Jamb us. If Jamb have jammed you before, that will not happen again. You are in the right place. Question 16 says, okay, let me quickly take my pointer. 4.0 gram of sodium hydroxide in 250 centimeter cube of solution contains 4.0 gram of sodium hydroxide in 250 centimeter cube of solution contains. Is this 0.4 moles per dm cube? Is this 0.1 mole per dm cube? Is this 0.04 mole per dm cube? Is 0.02 moles per dm cube? What they're asking you to find here is the molar concentration. Is what they're asking you. Use this mass and this volume to find the molar concentration of sodium hydroxide. So you must know that mass concentration equals molar mass. So the first thing we have to do here is to use this to find mass concentration, because mass concentration is molar mass times molar concentration. So we need to find our mass concentration. So 4.0 gram of sodium hydroxide in 2 centimeter cube solution. The mass concentration becomes 4 all over this 250 cm cube. But you have to convert this 250 cm cube to dm cube. Are you following? Because that concentration should be gram per dm cube, not gram per cm cube. So 250 cm cube converted to dm cube is 250 divided by 1000. So that becomes 4 all over 250 divided by 1000, converting 250 cm cube to dm cube. Do you understand? So that becomes 250 divided by 1000 is 0.25. Now 4 divided by 0.25 gives us 16. So the mass concentration of sodium hydroxide NaOH is 16 gram per dm cube. Now the molar concentration of NaOH, we need to find the molar concentration so that we say that mass concentration equals molar mass times molar concentration. So what's the molar concentration of NaOH? Very simple. Sodium is what? Na is 23, though it's not given. But you should let me see if it's even given. They are supposed to give that. They didn't. Okay. So sodium is Na23 plus oxygen has an atomic mass of 16 plus hydrogen has an atomic mass of 1. So 23 plus 16 plus 1 gives us 40 gram per mole. That's the molar. Oh, I made a mistake. This is the molar mass, not molar concentration. So this is molar mass. Molar mass. So that's 40 gram per mole. So mass concentration becomes molar mass times molar concentration, and we are looking for the molar concentration in dm cube. So if you divide both sides by molar mass, you have your molar concentration to be equals to mass concentration divided by molar mass. So the molar concentration of NaOH becomes mass concentration 16 divided by the molar mass, which is 40 gram per mole. So 16 over 40 gives us 0.4 moles per dm cube. So our correct answer is 0.4 moles per dm cube. That's option A. Very simple. Question 17. A major effect of oil pollution in coastal waters is the coastal waters, that's the seas. A major effect of oil pollution in coastal waters is the A, is it destruction of marine life? B, is it desalination of the water? C, is it increase in the acidity of the water? D, is it detoxification of the water? If coal oil spill on the ocean, what do you think will happen? Many fishes will die. That's the major effects. Destruction of marine life. All these other ones are stories. Increase in acidity. All those ones are stories. The major negative effects why we are clamoring on water pollution is destruction of living organisms. That's the main thing. So the major effect is destruction of marine life. So the major effect of oil pollution in coastal waters is the destruction of marine life. That is fishes, other marine animal organisms, and animals that depend on fishes for food, such as birds. So that's the answer. The major effect is what? Destruction of what? Marine life. And that is option A. Destruction of marine life is the major effect of oil pollution in what? The seas, which is the coastal waters. 18. In general, an increase in the temperature increases the solubility of a solute in water because an increase in temperature increases the solubility of a solute in water because A, is it that more solute molecules collide with each other? Is it that most solutes dissolve in the evolution of heat? Is it that more solute molecules dissociate at the higher temperature? Or is it that most solutes dissolve with absorption of heat? Let us see. Now I said that increase in temperature results to an increase in kinetic energy of the solutes and the solvent molecules. Because you heated them, the molecules both in the solid state, which is the solute, and the liquid state, which is the solvent, which is the water, will be moving, they'll be vibrating and moving fast. Heat, increase in heat brings about temperature, brings about increase in what? Kinetic energy. This increase in the kinetic energy allows the solvent molecules to more effectively break apart. This increase in the kinetic energy allows the solvent molecules to more effectively break apart the solute molecules that are held together by intermolecular forces, allowing the solute to dissolve as the temperature increases. So the answer there is that the increase in kinetic energy tends to affect the solvent molecules, and as they are vibrating, they now give it now what makes them to effectively break apart the solute molecules, which are actually held by what? Intermolecular forces, allowing more of the solute to dissolve in that particular solvent as temperature was increasing. So the correct answer is that more solute molecules dissolve or dissociate at a higher temperature. And this is assisted by the what? Solvent molecules. So more solute molecules dissociate at a higher temperature. Option C is the correct answer. 19. The relative high boiling point of alkanols are due to, is it ionic bonding? Is it ionic boiling? This should be bonding. Is it aromatic character? Is it covalent binding? Is it hydrogen bonding? So the relative high boiling point of alkanols are due to, let us see, I said that the high boiling point of alkanol is due to the presence of intermolecular hydrogen bonding in it. Intermolecular hydrogen bonding in it. So high energy is required to break the bond. Do you understand? So this is what brings about the high boiling point of alkanols. The presence of what? Intermolecular hydrogen bonding in it. Because you need more heat to actually break this hydrogen bond. They are quite strong. So the correct answer is there is what? Hydrogen bonding. Hydrogen bonding. 20. Given that 15.0 centimeter cube of H2SO4 was required to completely neutralize 25 centimeter cube of 0.125 mole dm cube NaOH, calculate the molar concentration in the acid solution. Calculate the molar concentration in the acid solution. A is 0.925 mole dm cube, B is 0.156 mole dm cube, C is 0.10 mole dm cube, D is 0.023 mole dm cube. So I said, you remember that H2SO4 is reacting with NaOH. So H2SO4 plus NaOH will give you Na2SO4 plus H2O. So you can see the mole ratio. 1 mole of H2SO4 reacting with these two moles of NaOH to give you 1 mole of NaH2SO4 plus 2 moles of H2O. This should be 2, not 1, 2 moles. But anyway, we don't need it. Attention is these two, which is H2SO4 and NaOH. So using the formula CAV over CVVB equals NA over NB, our titration formula, concentration of the acid times volume of the acid all over concentration of the base times volume of the base equals mole ratio of the acid divided by mole ratio of the base. Now we are looking for the molar concentration of the acid solution. So if you make Ca the subject of formula here, you have CVVBNA over VANB. When you make Ca the subject of formula here, so Ca becomes concentration of the base 0.125 mole NaOH times volume of the base, which is 25 cm cube of the base, times mole ratio of the acid Na, which is 1, all over volume of the acid. What's the volume of the acid? 15 cm cube times mole ratio of the base, which is 2. So when you multiply the numerator, multiply the denominator, divide the denominator by the numerator, you have 0.104 mole dm cube. So this divided by this gives you 0.104 mole per dm cube, and your correct answer is C, 0.104 mole per dm cube. Alright guys, we've come to the end of today's session of Learning with Prep Class, where we looked at past questions on Jamb Chemistry 2015, and we solved questions 16 to 20. Yes, we solved questions 16 to 20. So if you look here, we provided with a link. Type this link on your browser and load it. When you do so, it's going to take you straight to our WhatsApp group. When you join us on our WhatsApp, you'll be getting updates, you'll be getting infos on the latest content we have on our channel. I hope to see you in the next video. Please do not miss the next video. It is very paramount. Bye.